The beginning of this lab centers around this idea of functions or solutions given in a certain form, and using just the coefficients to actually determine what those functions are. So we'll set up some of those ideas here so that you're better able to handle what's happening in this lab. So this idea of functions of a certain form or a given form is something that you've definitely dealt with in the past with something like quadratic functions. So if I tell you you have a quadratic polynomial, you know then it's going to be of the form f of x is ax squared plus bx plus c, the a, b, c that go in the quadratic formula. And if I tell you a, b, and c, that tells you the entire function. So if I tell you it's quadratic, that gives it a certain form. And so to then determine the function, all I have to tell you is what are a, b, and c. And these three numbers determine everything about the function. Its zeros, its vertex, how it goes to infinity. All of these things are all known once you know a, b, and c. So in a sense, a, b, and c are really the important parts here once you know the structure is a quadratic function. Now for this lab, we're not dealing with quadratic functions, but the ideas behind it is the same. So for this lab, we have a differential equation of the form second derivative in y plus by equals a cosine omega t, and we can determine that using undetermined coefficients and our normal methods for solving these sorts of equations, that the solution is of the form y of t is some cosine coefficient, cosine of omega st, plus some sine coefficient, omega st, and then plus some forcing coefficient times this cosine of omega t term. Normally you would have to guess both a cosine and a sine for the undetermined coefficients part on this term here. Because there's no first order term here, we don't need the sine term. You can determine that for yourself. It's not going to be needed there at all. So this here is now the form of our solution, or the form of the function we're dealing with. There are four different unknown constants here. There's the AC, there's the omega s, there's AS, and there's AF. This omega here we know is the same as this one, so that's not too important. That came undetermined coefficients. But the three coefficients, AC, AS, and AF, as well as this frequency omega s, are the unknown constants in this function, and that's the form of the expression. If I tell you AC, AS, AF, and omega s, that will determine what this function is, what it looks like, how it behaves, everything about it. So the method given for you in the MATLAB code takes this differential equation here with initial conditions and determines from this information here what are those four unknown constants. Right? I have four coefficients here. From that data, I pick up four things here. And that's what the method does. It doesn't give you the function back. It just tells you here are the coefficients. It's like saying, I'm going to give you a quadratic function, and the method spits back just a, b, and c. While that's not the function in and of itself, it is enough to determine the function. If I actually then wanted an actual function out of it, I then have to build the function from these coefficients. And I can do that exactly in this form right here. So I'll get back all these numbers, and then I just write a MATLAB anonymous function, say y is at of t, then I write this exact form out with those coefficients going in their appropriate slots. So I'll write AC times cosine of omega s times t, and so on. And I write out this exact form, and that gives me a function that then took those coefficients and made an actual function out of it. Let's look at this in the code briefly to see how it actually looks in the MATLAB side of things. So here is the function given with this code. It takes in the parameters that we have, and it spits out four coefficients based on the problem at hand. It gives you exactly AF, AC, omega s, and AS. Now let's run an example of this real quick and see what we can do with that. So I go back up into this live script elsewhere. I can just run AC, AS, omega s, and AF equaling this method. Let's just put some numbers in here. 9, 4, 2, minus 2, and 3 from that section. And now we've got these variables stored. AC, AF, AS, and omega s. Now, how do I take that and make an actual function out of it? I write it all in the proper form. So I will then write my y is a function of t that is AC times the cosine term of omega s times t, the sine term, and then the forcing term. And here omega f was 2. I can run that again. Now I have this function, so I can plot it, do whatever I want with it. And there's the graph. Now that we have a function, we can do whatever we want with it at this point, But that's how we can take the coefficients that come out of the method and then build them into an actual function that we can then plot or do whatever we want with at that point. One last sort of comment on this. This idea only works when you know the form of the equation. For example, I couldn't take these AC, AS, whatever coefficients and use them to represent a quadratic function, right? Because the form of the quadratic function doesn't match the form I am given here. So you need to know the form matches before this sort of process works. If the form doesn't match, you'll get some weird errors, as you may or may not see while you're going through this lab assignment.